Hello guys, welcome to the new video series on linear integrated circuits, one of the most important subject for an electronics and communication engineer. Now this video is going to be an introduction video and I will try to give a basic idea about this subject and why is it so important to study it. And eventually I would list down all the topics that I'm going to cover in this series, so I would request you to please watch this video till the end. So without waiting, let's get started. Now starting with the subject name, what are integrated circuits? We can say integrated circuits are a keystone to modern electronics. They are like the heart and brains of most circuits. Now if you look at a circuit board, you can find these small black little chips that look something like this. I think this would be familiar. Now this is what an integrated circuit or IC look like. Now coming to the very formal definition, an IC is a miniature low-cost electronic circuit consisting of active components, for example transistors or diodes, and passive components, for example resistors or capacitors, that are integrated on a single crystal chip, mostly made up of silicon. So we can see inside this IC there are thousands of transistors, resistors, capacitors, diodes integrated within a single layer of silicon. Now the main question that comes in our mind is, why use integrated circuits? We have a lot of options available to us. We can design our own PCBs. We have discrete components which we can integrate and make our own circuits. Then what is the advantage of using integrated circuits? Now let me start with the very first advantage, which is miniaturization. Now, what is the meaning of miniaturization? ICs are extremely small in size. We can integrate thousands of resistors, transistors, diodes, capacitors within a very small space using the integrated circuit technology. Thus, this is what miniaturization means, and the ICs provide us with such an advantage. The next advantage I would say is batch processing. Now we can produce a large number of devices in one batch of production. Now producing a large number of devices within one batch will eventually result in the cost reduction. That is, the cost of manufacturing will reduce and the time required for manufacturing will also reduce. Thus, we can produce a large number of components within a very small amount of time and with much less cost. The third advantage is that there is no soldering process involved in our ICs. Now, we all have done soldering in some of our basic electronic projects, and we know that with time, the soldering suffers wear and tear and it might go off, and thus the reliability of the component will decrease. But in case of integrated circuits, there is no soldering involved, eventually resulting in higher system reliability. The fourth advantage of ICs is that it has a better functional performance. We will see later in the course that how using op-amps we can create large circuits and use it for various applications that have a really good level of performance. The fifth advantage of an integrated circuit is that it provides us with better operating speeds. The internal circuits in an IC are designed such that they can function very fast. Now as technology is improving, we are aiming for better operating speeds, and integrated circuit technology allows us to achieve that goal. And the final advantage of ICs is that it can work at a really less power as compared to other circuits. That is, the integrated circuits consume a very little power as compared to other circuits which are used for the same function. Thus I think this 6 points proves us that why we should use integrated circuit technology. Now based on the size of the chip, ICs can be classified into these categories. When there are 3 to 30 gates per chip, then it is called the small scale integration or SSI. This type of technology was basically used to manufacture logic gates or flip-flops. Now when there are 30 to 300 gates per chip, we call it the medium scale integration or MSI. These were used for making counters, multiplexers, adders that we have learned in our digital electronics course. Now when there are 300 to 3000 gates per chip, it is called the large scale integration or LSI, and these are mainly used for making 8-bit microprocessors, read-only memory, random access memory. Now when there are greater than 3000 gates per chip, we call it the very large scale integration or VLSI. This is the technology that is used mostly nowadays for the manufacture of 16 and 32-bit processors. And after that, there are complex technologies like the ultra large scale integration and the giant scale integration technologies. Integrated circuits or ICs can be classified into two categories. The first is the linear ICs and the second is the digital ICs. Now from the name linear ICs, we can guess that there has to be some linear relationship between input and output. For example, suppose y-axis is our output and x-axis is our input. So there has to be a linear relationship between the y-axis and the x-axis, that is the input and the output. So one example for linear integrated circuits can be op-amps that I will be covering in the next videos. And for digital integrated circuits, we know that there should be two states, that is either on or off. One example for digital integrated circuits can be logic gates. Now for 1 it will be in on state and for 0 it will be in off state. Now as the name of the subject suggests, we will be concentrating on this part throughout the entire video series, and in the next slide I will be discussing about the topics that I'm going to cover in this series. So coming to the topics that I'm going to cover, the first thing I'm going to talk about is the operational amplifier or the op-amps, which is the most important part of this course, and we should know every part of it in detail so that we can understand the other concepts easily. Now under the operational amplifier, we will learn about its characteristics like the DC and the AC characteristics, and we will also learn how to analyze the data sheets of an op-amp. Then we will see some applications of the op-amps, that is how to make the instrumentation amplifier, VI amplifiers, op-amp circuits using diodes, sample hold circuits, log anti-log amplifier, multiplier and divider, differentiated and integrated, and many more. Then we'll jump on to comparators and waveform generators, where we will learn about this mid-trigger, the astable multivibrator, the monostable multivibrator, and the triangular wave generator. Then I'm going to discuss about voltage regulators, active filters, the 555 timers and all the applications of it, then the phase lock loops or the PLLs, and I will end this video series by talking about the D2A and A to D converters. And I will be solving a lot of numerical problems that will help you to understand the topics and to ace your semester exams. So stay tuned, and if you like this video, please like, share and subscribe to my channel. Happy learning.